5, and yeah, quite looked at a lot. And yeah, so today we're gonna dive deeper into Starknet and Cairo. So this is our session 5. Yeah, and as well still I'm the tutor. So you can follow me on X, and you can follow my startup on X as well. Yeah, so in today's session, we are gonna look at quite in depth a lot about ownership, references and snapshots, scope, structs, packaging, or modules, but it's going to be quite a lot more practical than 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 theoretical. So have your boots ready. So basically, what is ownership in Cairo? So what do you understand by ownership? Because I recall telling us that every language has a way it handles ownership, and Starknet as well has a way it handles ownership. There is a way ownership is handled in Starknet. Yeah, so basically that's what we're gonna be diving in today, quite. And yeah, so ownership in detail. So each EVM, each variable in Cairo, first of all, has an owner, and there can only be one owner at a time. Yeah, so when the owner goes out of scope, so one has to understand it as this. So if at all I'm a variable A, and A has a value 10, so once A goes out of scope, yeah, so I see the any snapshot as well related to A gets out of scope. So one of the things we're going to look at in this session is snapshots, things like preferences. So we're going to look at that quite a lot. So we have what is called, so the Cairo VM prevents writing to the same memory twice, and I recall talking about that in the previous sessions. And then a copy trait is used as a workaround for this issue. So but we shall see that the copy trait, there are some data types the copy trait does not work with. For example, the arrays and dictionaries. So the copy trait allows simple types to be duplicated by copying fields without allocating new memory segments. Yeah, so we're gonna look at the copy trait in details. Yeah, there's a note for us here. Types like arrays and fields 252 dictionary cannot implement a copy trait because their manipulation is in different scopes is forbidden by the type system. We're gonna look at that. So then we are gonna look at snapshots. So what do you understand by a snapshot? So snapshots, we can understand them as a view into the past. Yeah. So memory, I want us to understand that memory is mutable in Cairo. Yeah. So what snapshots help us is, in everything we do is that we try to minimize how much memory we are using. So a snapshot gives us a view of maybe an object or maybe a variable into of it into the past. Yeah, because memory is immutable, so you cannot change what is in memory. So this is gonna be quite a lot of practical session. So let's follow the Cairo book for more details. So yes, minimize this. So and yeah, of course, I understand many of us know where to find the book. So it's book.cairolang.org, and yeah, it's because we've been using it quite a number of times. So our first segment is gonna be into ownership, yeah, into understanding ownership. So ownership, so because we understand that Cairo has a linear type system. So Cairo uses a linear type system, and in such a system, any value, a basic type, a struct, and inner must be used and must only be used once. So you cannot you cannot use the same value twice. Yeah. So used here means that the value is either destroyed or moved. Yeah. So if at all I have two functions, and there is a function A which takes in which there is a function A which returns a variable which returns a value. There is a function A which returns a variable with a value 10, and if at all this function passes the ownership to another variable in another function B, so it's like we have destructed, we have destroyed that the variable A. So destruction can happen in several ways, and one of the ways is as follows: a variable goes out of scope. So if at all I have a scope, yeah. For example, we've been working with the. Let me show you to us in practically. So you can make a directory, call it session 5. Let me now change to sample session 5, and let me open my VS Code here, right here. So I've opened my VS Code. So it's opening. Yeah, it already had some files within. I think at this moment we turn to how to understand how to do. So if I'm having a previous copy, and then if I say let so if at all I come here and I say rectangle, if I come here and say rectangle A, um, I can say let's right equals to rectangle. Like here, so here I can print my height is, and I can have my print my height. So when I come here and say, because now this is the scope, so I can comment here like entry into the scope, opens. So now if I come and try to print here, This my height here does not exist here because the scope has already ended. Yeah, so outside of these curly brackets, my height is exist. So that's what I'm trying to mean, guys. So as a variable goes out of scope, just like here, this variable has gone out of scope. Our variable, that's an instance, but now our variable my height, it has gone out of scope. So when you try to access it, it's not in the outer scope, so it has to return an error. So then as well, when 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 a struct, that's why when I try to, so it's very good every time you are maybe categorizing data in a struct, you have to add these traits here, the copy and the drop trait. Yeah, and guys mark this so you cannot use the copy trait in an array and in a dictionary. Yeah, so but with struct it works properly. So you, because when you stop using the struct, like in this case a rectangle, it goes out of scope. So and that's why we have to drop it, just like in other languages like C++, you find that there is, you have to, and like in C, you have to free the memory. Yeah. So even here we drop whatever that is no longer being used, we drop it from the memory. That's why we use that drop trait right there. So we're gonna look at ownership. Yeah, so we've looked at scopes. So we can look at, so we have looked at scopes right there. So we have this function right here. Very good. There's a very good concept here. So in this concept, in this function, so in this function, we have, we all, of course, at this moment, we all know what the pop front method does. So the pop front method, it removes from the start. Remember, when you're adding to an array, you add to the end and remove to the start, from the start of an array. So the pop front method removes from the start of an array. Yeah. So here we will see that we are, I say that you're moving a very simply means passing that value to another function. So when that happens, the variable referring to that value in the original scope is destroyed and can no longer be used, and a new variable is created to hold the same value. So let me try and access it. So if at all, every time you're trying to reference maybe a struct, maybe an array, maybe any object, you don't need to store it entirely in the memory. So that's what snapshots basically help us with. So you basically don't need to store that very object. So by me using a snapshot, I can it's like I'm trying to have something which which gives a reference to that object, but without actually storing that object. So in that, like, I'm trying to store a reference, I'm not trying to store that very object. So that's basically what a snapshot is all about. So, and yeah, just like in other languages like Rust, C++, C. Yeah, we look pointers. You can look at pointers as a similarity, but in Cairo we call them snapshots. So still following the book.cairo lang. So in the previous, so now we're going to have a practical approach of how snapshots work. Let me create here a function. Let me create here a function and let me call it understanding snapshots implementation. So let me have a function here. Yeah. Maybe create rectangle. Yeah. So this function is supposed to take in a snapshot. Yeah. Or let me call it actually, yeah, create a rectangle. So this function is taking in a snapshot. Yeah. Maybe it's returning a rectangle. So it's taking in a snapshot. So what do we want it to do? So basically, this, so it's taking in a rectangle, and it's as well taking in a side length. So it's taking in, because we are attempting to create a rectangle, and the rectangle has a length and a width. So so then what are we returning? So we are returning the rectangle, whereby, so we are passing, we are referencing a rectangle. So the snapshot is referencing a rectangle. Yeah. So now we can be like, okay, actually what I need to do, let me do this. Okay, let me first do this. So let me, yeah, so my function is attempting to create a rectangle. So basically a rectangle has a width and it has a height. Yeah. Or okay, let me just make this a bit easier. Okay, let me just create here. Let me just create here. Let me create here. So let me do this. I'm trying to come up with a simple function that we can use. What am I? Okay, let me just refer a little bit the book. Okay, I think I get what I'm doing. I'm doing graphs. Okay, yeah, I actually, this is supposed, sorry. This is not supposed, this is not supposed to be a self, so this can be your pointer. So let me call this get total area. So remember that formula. So to get a total area of a rectangle, all we need to do is we say all we need to do is rec. So the total formula is so the total area is 2 times length plus 2 times width. Yeah. 2 times length plus 2 times width. So we are dereferencing the snapshot. So to do that, we say we first add a asterisk first, then we say dot length. So in our rectangle we have height and width, so we can say dot height, yeah, plus 2. Actually the simplest method can be now bringing the 2 out, and then it becomes L plus the height plus width. We can use the brackets here and just say that yeah. So by us doing that, we are trying to get the total area. So it's supposed to be a U64 rather than a. So we are using a snapshot, yeah. We're using a snapshot which is referencing the rectangle struct, yeah, and we are trying to get the total area. So the total area here is 2 times rectangle dot height plus rectangle dot width. So that gives us the total area. And here we can just come right here in our main function, yeah, and just be like rec dot get area, and then we supply it. This is just supposed to be get total area. Then we pass in the, so we're supposed to pass in, so let my snap equal to at rec. So this is my snap. So my snap is now the snapshot. Yeah, so that method is supposed to get me, because this is a snapshot right here in practice. So this snapshot is making is a view onto this instance of the rectangle. So basically, this method is supposed to get us the total area. Yeah. So that's basically how we can use snapshots. So you can think of anything. So what snapshots are helping here is that basically I will, if at all I'm not adding a snapshot here as my parameter, I would have to just add a rectangle as a struct. Yeah, but that consumes a lot of memory. That consumes a lot of memory. So that's why we opt to. But when we pass the snapshot, just that means we are not consuming a lot of memory because we are not storing this very object in memory. Yeah, so it's a bit similar how the pointers work in Rust and C++. So it's pretty like a similar concept. Yeah. So basically, the snapshots help us to, you know, we are trying to call an object by not actually storing that very object in memory. Yeah. So basically, that's what is snapshot. And so after now you've so after now you've assigned a snapshot to your object. Yeah, just like you can see here. So to this a snapshot, to this snap means like to get the actual contents of the snapshot. That's when we use the asterisk operator. Yeah, so that's when you that's when so by using the asterisk operator, you're trying to snap. You are trying to unpack what's in this snapshot. So when you try to unpack, you get the actual contents of the snapshot of the you get the actual contents of the object that the snap is kind of trying to that's the that's the snap is trying to point to. So that's why you see here, if at all by me saying so to get the actual object, first you first start with the asterisk, then the name of the snapshot. Because now since the snapshot is actually referencing the actual object, in this case a struct. So when I say dot height, it gives me the height of the rectangle. So then now that gives me the height, and then when I come here as well and say rec, which is the name of the snapshot here, dot width will give me the width of this object. Yeah, this object, which in this case is this instance, which is being which we are trying to refer to. So basically, that's it about uh, uh, snapping and snapping. So we are gonna use them pretty a lot in our code because they save us from a lot of hassle. They save us from a lot of hassle. So basically, that's how you use a snapshot, and then maybe you're trying to ref you. So your snapshot is trying to your snapshot is trying to get the contents of maybe a struct, and maybe it tries to make like a change in either of the contents. For example, this struct here, so it's having height and it's having a width. So, but then now maybe I want to to maybe now want to maybe I want to change, yeah, the variable, yeah, to change the variable maybe of the width, or to change the variable of the height. So that's when mutable references come in. So this is a pretty as well as similar concepts in things like in the Rust programming languages, where you have a mutable, where you have a mutable reference, yeah. So still, if at all you had not declared your snapshot as mutable, yeah, so you cannot change anything, yeah. So your snapshot first, because it's pointing directly to the object which you are trying to like to reference or to what. So basically, to change anything, you have to as well declare. Uh, so by us using mutable references, we are able now to, you can see like in this example right here. So this is a pretty similar concept as well. So when you're trying to change, I know in languages like Python, when you try to interchange, for example, if at all let me have a function here, maybe interchange. So in languages like Python, in case here I have A, maybe it's a U8, and then B, which is as well maybe a U8. So it's not returning anything. So in languages like Python, you just say A is equal to B. Yeah. So when you say that, it's like you have interchange. It doesn't work like that for Cairo. Yeah. So for languages like Cairo, you first declare an empty cell in memory, so it can be a temporary cell, and then now we equate that temporary cell to A, and then you come and say A equal to B. Yeah. So first we have an empty cell. Now we get whatever is in A, we first fill it in this empty cell. Yeah. And now A, that means A is empty. So now we get whatever. Now, so that means A is empty. Now we get whatever what was in B, we put it in A. Yeah. So whatever was in B, now we put it in A, and then we clear whatever. So then we set B. So whatever was in A, because now A has remained, so we first create an empty cell, yeah, in memory. And because it's empty, that means we can fill it with data. So now we get whatever was in this case here A, yeah, we fill it in the empty one. So that means now A is empty, yeah. So now we get whatever that was in B, then we put it in A, then we declare B as temporary empty, so as empty. So basically that's how it's done. Yeah, that's how you flip. Yeah, so in flipping, yeah, so I recall saying that So yeah, so you realize for such a rectangle, so this is where a mutable reference. So to assign a mutable reference, yeah, so we use the name of the reference. So then to pass it in as mutable, we just pass it in and we start with the ref, then now the name of the snapshot. So that's how we assign a mutable reference. So we're gonna see the mutable references as well. We're gonna use them a lot because if I truly want to change maybe the orientation of a struct, so basically you find an implementation right there for mutable references. So basically that's it for mutable reference. So snapshots are good and they, as I said, they limit, they don't consume a lot of data. So basically we are gonna be following the Cairo book. Yeah, so now we're gonna go into some very good concepts, and this is called structs. Yeah, so basically structs are really good. Yeah, so it's another way of structuring written data. So and another good thing with structs is that, so structs just like tuples. So in a struct you can store data of different data types. For example, I can have a user, yeah, and this user has a name. So name is a byte array, which is a long string, and then this user can have an age, yeah, and then this age is as well a what? This age is a number. So basically, I'm storing that, and then as well, this user can have maybe. So in the user struct, I can as well have what else? I can as well have an array stored in the user struct. So basically, that's what I'm trying to inform us about. So probably we've looked at structs already. So this is how you create a struct. So you start with a struct, a keyword followed by, so here I'm creating a user struct. So my user can have a name, yeah. My user can have a phone number, and my user right here can have must have an age. So then my user can have a nationality. So basically that's it. So my user has a name, and this name is a byte array, yeah. So then my user as well has a phone number, and then my user has an age. So and then a nationality, which is a byte array. So you realize that all these are different data types, but within a single struct. So basically, that's what I meant, that in a struct we can have different data types. Yeah. So And then it's always good practice to add. I believe it's not new to us that we are seeing this. So remember, all these languages are keen on memory. So after we've used something, we must get it out of memory. Yeah. So that's why we attach a drop trait onto it. So after we've created our struct, we must find a way of how does this struct, if at all we are no longer using it, how does it get out of memory? And this is very key in very many compiled languages. So various compiled languages. So you always have to, after using something, you have always find a way of freeing that thing from memory. Because at the end of the day, yeah, we want our program to be efficient. So that's why we add this drop trait. So you don't need to cram it. So you just need to know that this is how you add it to it. So when you add it there, it means now the compiler will know that after this struct is no longer used, it has to get out of memory. So basically, that's it. So now that thing is so then after creating our, for example, user here, of course we saw how to reference the user. So this is how you reference the user. So you create the user one is the variable, then I call the struct keyword, which is user, and then now I can create my user. So user has a name. So let me say here, check. This user has a phone number. You can give a phone number, maybe +254. Then this user as well must have an age. Yeah, say an age can be 40. Yeah, then just like that. Then you have to add a nationality as well. So then so if at all I want to get any of the properties of the struct, yeah. So let me add nationality. Yeah. So maybe this is like Kenyan. So now I added the nationality. So now if I come and say let user phone number equal to user one dot phone number. So by me saying that, that means now this phone number of user one, I've copied it and put it into this variable user phone number. So basically that's it. And there's a good concept here. So let me just refer to this. So if I told maybe I have two users and these users share some properties in common. So maybe here I'm having new user and here I'm having, or maybe I have user one and I'm having user two. So if at all the only differing things in user two from user one are name, phone number, but age and nationality are the same, I don't need to rewrite everything. I just come here and say user one. Yeah, it's similar to that React, that command which copies like copies details of one object to another. So basically, by me doing that now, I've copied the remaining details of user one. I've copied it, so that copies the age and nationality, because I've told it that, hey, I don't want to rewrite everything, so it will make them the same. So basically, that's it. So we're gonna use we're going to use structs a lot. We're going to use them a lot because they are a good way of how we can categorize data. So basically, we're going to use them quite a lot. Yeah, so I think we've covered most of. So the other thing is structs is that I just like with so structs as well can have implementations. Yeah, so can have methods, of course they can have functions, so we can have a look at the methods and functions. We're gonna have a look at how to have things like methods, how things like functions within our struct. Yeah, so um, basically, yeah, so you can create a method, you can create a file here and give it an name. So I decided to give mine with methods.cairo. So I can come over here and then create a new struct. So you can have as many structs as possible. You are not limited to any, so you can have as many as possible. So it's not like you are limited. Yeah. So let me come and have my struct here, user. Let me just go up and copy it. Okay. Okay, let me have my struct here. Yeah. First we know its name. It's a byte array. Yeah. And also let's just take age. Let's give age to be let's give age to be a U8. Yeah. So let's give it to be a U8. So then after having our age, so let's have so the copy trait, of course, just copies the struct. Yeah. So remember, guys, I said you can have as many structs as possible. It's not like you're limited or what. So after doing that, then I can come over here and create. So a trait is like where you declare all the functions and the methods of of the struct which you have constructed. Yeah. So here my trait is user trait. Yeah. And I want to have a method which returns. Let me just write a blueprint here. Methods return name of the user, return the age of the user. Yeah. The other method should be The other method can be to change the age of the user. Yeah, so now let's have a blueprint. So we put the blueprint in the trait. So a trait is like how you see how an interface is used in TypeScript. So that's what a trait is. So we can be here, get username. So it's taking in, of course, because so a method is talking to the object itself. So that's why we start with a self keyword. Yeah. And yeah, let's reference a snapshot right here. Yeah. So it's gonna return. So it's gonna return a byte array. Yeah, because our name here is a byte array. So we are having another method here which changes the name. So it as well takes in self. Yeah, so it as well takes in the self keyword and then it's referencing uh the user structure as well. So it's returning a U8. Yeah. Okay, actually it's taking in as well new age because we are setting a new age. So this is U8. So it's not returning anything after because we're just setting a new age. And then how can we I think we can have just a fun function. We can have a fun method which returns the age of the user in 10 years. Yeah. The age of the user in 10 years time. What will be the age of this user? So basically that's what I'm trying to do. And then so this method is going to be like, first, how does this method work? So if at all to get, of course, okay, get user age after years. So of course it's referencing self at user. Then after how many years, then it's returning U8. Yeah, so years, this is a U8 as well. So how do we get a user age right now? So first of all, yeah. So this is just a blueprint. Actually, I started working on it. So now this is a blueprint, guys. So that's a blueprint to whatever functions we are gonna have. Yeah. So now, so in your now you can understand like a trait where you declare the functions and the methods that you're going to, which are going to be attached to your struct. So after doing that, then so we can have many implement blocks. You can see there's already an implement block for a rectangle. So we can have another implement block for user trait. Yeah. So how we so implement block is when you define function methods which you declared in the trait. Yeah? So and this is the format. So user so you just start with the name of the struct followed by implement block and then the name of the trait. So after doing that, then you come here. Now I come here. So now I'm defining my method get username. Yeah. So it's a self. It's taking a snapshot to the user struct. And then it's returning a byte array. Yeah, so we are returning self dot, yeah. So in our method, we are returning self dot user, yeah. Self dot self dot get self dot name. Okay, I'm forgetting. I think it's self dot self dot get name. Yeah, it's like that. So no, we're gonna run it and see whether it's that or so. If at all you have any query, I like using I like using I like using DeepSeek a lot. So there's nothing you don't need to cram anything. So you can just be here and you just confirm something. So you can ask DeepSeek if at all you can just ask DeepSeek here. Start a new chat. So what I'm trying to do is that so you can be like how do I get how do I because I'm confusing it with some other way, so that's why I'm asking it. How do I return the name from so then it's gonna give you the answer. You don't need to cram anything. Um so yeah, it's rectifying a few issues. Yeah, so it's actually supposed to be self.name. Yeah, I was confusing it with when you're writing, when you've already written a smart contract. So it's self.name. So that gives me the name, the username. So now if at all I want to set a new age, my first variable will be self. Then I'll pass in the user, the new age, what new age I want to. So it's not changing anything. So 25 itself age, as you know. So age equal new age. What is my, yeah, yeah, that's right. Yeah. So then I have another function, yeah, which gets me the years after a specific time period. So I can just be like, um, I can just be like, get user age after years, then setting in itself, setting in itself, then the numbers, and then do 20. Yeah, so it's returning a U8. So basically, this will be self-end as plus 10 plus, yeah. What is it's giving, my deep secret is giving me, yeah, above in Cairo language implementation. No trust, because it's easy for it to give you Rust implementation instead of Cairo. Yeah, so basically that's how you use the methods. Okay. Yeah, so yeah, actually we had made a mistake, guys. But this is right. Yeah, actually there's some error we had made here. Yeah, so since we are here trying to set, so this is supposed to be this right here. This is supposed to be table. We're supposed to use a mutable reference compared to using using settings trying to do trying so what setting is trying to do is trying to what setting is trying to change, so it's changing the actual edge which is being set, so that's why we need to use it here. So what setting is trying to do is to so what setting is trying to do is to because we are changing like something in edge, so that's why we need a mutable reference. That's why you see that here. What else haven't we done right? Yeah, so here we are actually supposed to use, because we are dealing with snapshots, so here we're supposed to use uh, we're actually supposed to use a mutable reference. We're supposed to do snapshot like that. And then here we're using a mutable reference, again a mutable. So what else? And then yeah, so this is as opposed to because we're using a snapshot, so this is supposed to get the edge by using the snap, yeah. So basically that's it. So now when I go right here in my main, and then I be like, I try to create an instance of a struct. I can be like my user. I can be like my user equal to user struct. Yeah, and then I can create a user with name of boss age. I can put 50. Yeah, and then so when I say, so if at all I want to get the user's name, or I can just like print ln. If at all I want to get the username, my username is, then here I can say my user dot get user. So basically, I'm trying to, this is a method to the struct user, so I can use that method to get the username. So basically that's a method. Yeah. So we will be using struct quite a lot in our actual smart contracts. So just to go back to our book, what does it say? So we've looked at that. As well, you can have functions would have the functions of the soft keyword compared methods. It's a method talks to the actual, like, can I call them attributes of the struct, but a function does not. So that's the difference. So just like here, function. So this is a function. See, it does not take in a soft keyword. Yeah, you just only pass in the parameter. It doesn't take in a soft keyword. So that's the only difference between function and the method. So the other bit is looking at terms. So we are not going to dive quite a lot in terms. I think so. All in as well. As well, another data type. Yeah. So but we're just going to go briefly about it. And then can as well, the way you see how you write methods on structs is the same way how you can write methods on enums. Enums can as well have methods. Yeah. So basically, I can use enums maybe if at all I'm having a sequence of data which I need to categorize. I can use enums for that. When I have predictive data, I can use enums for that. So enums are a way to define a custom data that consists of a fixed set of named values. Enums are used for representing a collection of related values where each value is distinct and has a specific meaning. So for example, here, this is an enum for direction. So we know we have north, east, south, and west. Yeah. So I'm not going to dwell a lot on them. Yeah. So we looked at match and flow. We looked at if cases. We covered that. We covered that in some of the previous sessions. So yeah. So this example, if you have if let, so you can have an if and you can have a let. Maybe just look at here. So we can use some in a situation whereby, for example, if at all I'm trying to query an API, but I know this API can give me data, or it can maybe it's supposed to give me a name. So, but this API can give me a name or it may not. So there are cases where you have to return something where you want to either return an element or none. So that's where sum comes into place. And yeah, so while we are going to go briefly some of the things. So then managing Cairo traits and So this as your project gets big, guys, there comes a point where you need to, like, you cannot have all the functionality in one module. So and just imagine you are collaborating with other colleagues, maybe they're from various countries. So you need to find a way of maybe categorizing your project. And yeah, so just like how you see my code structure. So the lib Cairo is the main is the main driver file. So if at all I want to run this, I will just say with methods. Yeah. So when I say with methods, yeah, it calls the with methods module into context. Yeah. So by saying that, I've now called this module, yeah, I've put it into context. So that's why you see, why is it complaining about here? So now it shifts all its focus to here. That's why it's complaining that I'm having here um, an error, so I'm supposed to import. Yeah, so we're gonna have a look at some of that. So basically packaging helps us to package our data. So, but I want us to go and look at Starknet Foundry. So Starknet Foundry is a framework for enabling us write Starknet smart contracts. So a framework, where what you can understand by a framework is anything that helps you write something quickly and efficiently. So it's not only helps us to not only helps us to write smart contracts, but it as well helps us to write tests for our smart contracts. So basically, that's what Starknet Foundry does. And I think I've worked with this, so I'm gonna close this. And we're gonna be following. So for Starknet Foundry, in case you need to know anything, you can as well just search it, Starknet Foundry. Yeah, I shared a lot about it. Like I sent a link in the group about it. So basically, I want us to understand it as a framework which you can use. Guys, testing is very crucial in writing anything on the blockchain. Remember, you have to ensure that the chances of this thing failing are very minimal. So the more tests you do, the better. So that's why testing is really crucial. And so this is how you install on Linux and Mac OS. And this is there. So they've given us instructions on how to install, and still it needs you to have Rust installed. So these are the various ways how you can install. And then after that is done, so to check the version of what you have, you can just go here. So let this be SN Forge. Yeah, so after going through the installation, then you run SN Forge version. It will give you, to let you know that you've installed it successfully. So this is how you initialize a project. So I already this that's how you initialize a project. So you can just be like SN Forge new, then then you can be here whatever name of your project you want to be. So let me call this, okay, so it's complaining. Why is it complaining? So let me see. Why is it complaining? So let me just say to find out. So here it gives me how to initiate. Okay. So I'm instead supposed to use the init command. So I'm supposed to be like snforge init my strk project. So when you do that, it generates for you a project structure, yeah, with Starknet Foundry installed. So Starknet Foundry is a good tool for running tests that's why we use it quite a lot. So it's like a framework where you can write your smart contract, and then you can write your test as well. So now, so let me open my project right there. Yeah. So um, I have some project here, some simple smart contract right here. So just a simple smart contract to set the greeting, to get a greeting, and then to just to get the greeting count. Yeah, so similar to to how we've been seeing it in Cairo practically, is that so we have to in the interface. So this is a trait in the trait. So since the name of my so I say to call it hello. My module is HelloStarknet. So this is the interface. So I'm going to so this is like where you put like a blueprint of the methods and functions. So I'm going to have a function here which takes in a mutable reference because it's changing a greeting. As well, I'm going to have another function here, get greeting, which returns the greeting. And then, so after putting them here, then, so this is now, you have to declare to add this attribute here, that is an interface. Yeah. And then as well, you have to add this here. Yeah. That, this is my contract. So the contract is the module. Yeah. And then so inside the module, then you come and so in our storage struct. So storage struct, I want us to understand a struct as a storage struct as this. So anything that I want to be stored on the blockchain, I have to put it under the storage structs, just like how you are designing your database in Web2. And maybe you have a name of a user or a user. Yeah, so a user can have a name, a user can have age. So anything that you want to store on the database, in this case the blockchain, you have to store, you have to put it under the storage struct. So literally here we want to have a greeting and greeting count. Now here, so basically that. Now here I'm trying now to define the functions. Yeah, I'm trying now to define the functions that I've already declared from the trait here. So, and in here, so I have a function which says the greeting, because it's changing the initial greeting, so it's taking in a mutable reference. We talked quite about mutable reference, and then the new greeting. So self.greeting.write. So I want us to understand. So in blockchain, we have two vital methods, and these are set and write. So you can understand a set as similar to, you can, it's get and write. So write is like how you understand a post method. When you're writing to the database, use a post method in Web2. So when you're writing the blockchain, use a write method. Yeah. So that's why you say self.greeting.write. So this this here changes. So what this does here, it changes the greeting. Yeah. And then, so after changing the greeting, I want it as well to change the greeting count. That's why you see that it's writing to to it's writing as well the greeting count. So we have greeting count. So it's as well adding, because after setting the count here, uh we so after setting a greeting here, the count has changed. That's why you see me adding one. And then now this, so the get method in Starknet is read. Yeah. So the read method does not consume gas fees, because it's just a get method. So there we're just reading, and then also this we're just reading. So basically just a simple smart Starknet smart contract. Yeah. So basically that's it. And so we add this attribute here because we are going to talk directly. So after deploying a smart contract, you'd want to talk to these methods. Maybe you're writing a test, or maybe you're trying to access an API. So by us adding this, it means that we can be able to call each of these methods in our test. So basically this is the format of how a simple Starknet smart contract looks like. So you have an interface, and then you have a module. So the module is the smart contract. So mind you, the main thing here is that you must have a storage block. So you must have what variables are being stored, what variables are stored. So that's why you have a storage block. So then after doing that, you can write your tests. So I'm gonna be able to push this work on my GitHub, and I will avail a link. So when you're writing tests, as I said, tests are very crucial because we need to write more tests as often as possible. So when you use, so if at all because we want to declare a contract, and then we want to deploy it. So this is what we use. So this is just call it. So this is from Starknet Foundry. So declare function registers your contract's bytecode with Starknet testing environment. So it prepares your contract for deployment in tests and then returns the contract class. So for you to deploy, you must have a contract class. And then now the contract class trait, all it does, it provides the deploy method. So this line here is very, very crucial. So after doing that, now we want to call, because we want to work with with the with these methods right here. We want to work with these methods right here. So, but we can only be able to access those methods through what is called the dispatcher. So we try to import them. So sample with test is the name of my project. Then HelloStarknet, you can see, is the name of my Starknet smart contract. And then I've well added a public keyword because I have to add here public to make sure that if at all I want to access this, it's accessible from anywhere. Yeah. So as you can see, test is not within the directory. So now these dispatchers help us to to call those functions which require which it helps us to call functions which are get alright. So so the above imports, these imports, the above imports the interface trait for the so so the HelloStarknet dispatcher trait, it helps us to get access to the mutable, the state changing, the the state changing in this case it's this dot trait, yeah. So this dispatcher trait helps us get that, and then the self dispatcher trait just helps us to read all those functions which don't need to, which are not stating, which are not mutating the state. For example, functions like get greeting count. So we access those functions using the Starknet HelloStarknet self dispatcher trait. So then after doing that, this is how we declare our contract class. This is how we declare our contract class, because we have to first create a contract then deploy it. So after deploying it, now this is, we said that, I remember telling us that the HelloStarknet dispatcher tells me get access to the the functions which are changing the state, and then self dispatcher only helps me get access to the functions which are not changing the state. Then here I'm writing tests, firstly I've set here expected greeting. So now, so when you're testing, basically you're using assert keywords, and yeah, so when you're testing, so when you're testing, basically what you're trying to to do is basically you are checking, is this like this. So basically that's what we are trying to do. So that's why you see that at first, so initially there is no greeting set. So now I've set the greeting here. So what the into does here, it converts from one state to, from one data type to another. So that's why, so assert, yeah, get greeting count. So I'm using a, so you see self dispatcher helps me to get the, it helps me to get access to the function, the methods which are not changing the state. So that's why you see, and then dispatcher is helping me get access to the methods which are changing the state. So I first get initial count, which should be 0, and then greeting because there is no any greeting. So then after that I set a greeting, then So here the greeting should be this, and then the count should be 1. So basically that's our simple test. So but when we are in our session where we're connecting the front end to smart contract, we are going to have a detailed look into having a more detailed smart contract. But yes, so basically we are gonna stop there for now. So but basically that's how you write a smart contract, and that's how you write a test. So I'm gonna be able to push this work on my GitHub, and you can be able to access it